We're going to continue with tidal power. So tidal power is the movement of water, like we talked about just briefly at the end there. But it's what turns those turbines and it creates electricity with that generator, okay? So it's caused by the gravitational attraction between the sun, always important, Earth and the moon, and the tides moving in and out, all right? But they're moved as the tides rise and fall. You turn these little turbines right here in the middle, right? But there's obviously going to be some issues here, okay? But some countries like France, Russia, and Canada, and also out in the Pacific a little bit, Japan's getting involved in this a little bit, and Australia actually is getting involved in this a little bit. But there are some downfalls, obviously, to this. You're putting stuff in the ocean, right? I mean, fish don't know what those are. They're going to swim into those, very similar to the wind turbines. And it just creates a little bit of a underwater debris, underwater stuff that's not usually there. So that throws off fishing. It throws off the fish's lives. It also has some economic impacts with fishing and closer inshore fishing and shrimping and stuff. Ocean thermal energy. This is an experimental power station off of Hawaii. This is actually pretty cool. The problem with it is that the energy needed to run this pump is about a third of the energy you're going to collect. But what it does, it shoots down some cold water down into the depths of the ocean or some pressure, and the cold water comes up, and it's just like this cycle of warm, cold water is, again, turning the turbine. Always, the turbine's always important. But again, the energy to run this station it uses about 1/3 of all the energy that you actually collect or produce for this station. Hydrogen is another alternative energy we have out in the world of science. And hydrogen is the most abundant element in our universe. Water, H2O. The H is hydrogen. Hydrogen's everywhere. And it can be burned as a fuel. All right? So it's found on every living molecule on the planet, and it's also found in water. It's, like I said, it's the most abundant element in our universe. But it doesn't release any pollutants when you burn it. And in the future, we may be able to grow plants and produce hydrogen cost effectively. But hydrogen energy is really expensive. And also, it can be dangerous. Like, there's a reason why we have something called a hydrogen bomb. It's splitting a hydrogen atom. Lots and lots of energy are in there. Lots of energy. But it also can be destructive. So this is not on the market in this full-blown marketplace, but it's some experimental stuff we're doing. Sweden, I think Sweden or Switzerland, one of those countries. One of the Nordic countries over there, Sweden or Switzerland, is actually experimenting with this a little bit on a larger scale, but they're not releasing it out to the public and collecting the energy to do that. So, because there is a danger side to hydrogen splitting. All right, so when we look at all this energy, we want to know how efficient it is. So energy efficiency is the percentage of energy put into a system that does useful work. Okay, so how much energy am I putting into this system, and how much am I getting out? So the equation for energy efficiency is a percentage equal to the use in minus the energy out. All right, or energy out divided by energy in. So you're trying to figure out this relationship: how much energy am I putting into this, and how much am I getting out of it? So that ocean thermal is a good example. That one uses a higher percentage of energy. All right. So the energy going in and the energy coming out, we talked about this several units ago, but it's called the first law of hydrodynamics or thermodynamics. But this is when we're looking at the energy unit, but we're just relating it again. Okay, so looking at it again. Efficient transportation is also something we're looking at. So the internal combustion engine is what drives a lot of the non-renewable energy, right? We use a lot of fuel to power automobiles. But according to the book, the reason the U.S. does not have fuel-efficient cars like other places is because gas prices are so low. I mean, you see our gas prices right now are around $2.70 a gallon, which people are like, oh, that's sort of high. But you go over to Europe, you're looking at $5 and $6 gallons. You go over to Asia, you're looking at $5, $6 gallons. So our fuel in the U.S. is actually really low compared to other countries. But you look around, you see a lot more hybrid cars. You see a lot more electric cars. And a lot of these companies like GM, they're looking to move a lot of their stuff over to electric cars. Audi and Volvo and Volkswagen are all looking to be all electric in by 2025, 2030. So very soon, you're going to see these companies turning into overall all electric. There are downfalls to electric. I mean, lithium, you're mining lithium to get lithium batteries. You have to mine, we talked about that the last section. Mining can be destructive to environments. Also, getting rid of lithium batteries, you can't just throw them in the trash. You have to especially manage these. These go into the hazardous waste category we talked about recently. So there are downfalls to electrical cars as well. Cogeneration is also something we look at. This is when you produce useful forms of energy from the same fuel source. All right. So this would be like using hydrogen. Like say you're using fuel. You're burning or you're in the biomass. So you're burning that and collecting that energy. You're using it for multiple things. All right. So you're using it to heat a building. You're using it to heat water. That stuff. Okay. And also energy conservation. That's one thing we always talk about in those classes. How can we conserve stuff? So that just means saving energy and where you can. All right. So ride your bike instead of driving. That's not really efficient here in Walton County. You live in Atlanta and you work in Atlanta. That's very efficient. Making sure your windows and doors have good sills to them. Turning off lights when you're not in a classroom or you're leaving your room. Those are small